Hello everyone, my name is Wang Gang. Today I will be introducing our work on recommender systems. The recommender systems has been applied in many different fields. However, traditional results are always too similar to the interaction history. For example, the systems may recommend cheaper phones to the users who have already bought phones. It will make users feel bored. To solve the problem, thing has been included to increase diversity. However, the application range of things image is limited. Without image data, how to define a thing and incorporate information into existing CF models. In this work, thing is defined as a set of item categories that occur frequently in a real-life situation. The formal definition overcomes some weakness of image things. Compared with the traditional recommendation, thing-based models have a greater chance to perform better with help of things. Uh, Now, let's show some details. The important part of this work is the form definition of things. To incorporate thing information into items, we design a hierarchical network with 3 layers. By utilizing the category as an intermediate, it can avoid trouble caused by frequent item updating. User item bipartite graph result their interaction histories. Given bipartite graph and thing-based graph, the target of thing-based recommendation is to predict user reference. First, our approach use graph neural network to propagate thing information and model each items. Then it learns user embeddings from interaction history. Finally, it integrates users and items to make predictions. Since each item exists in 2 graphs, uh, our approach learns item representation in each graph space. In the thing-based space, we explore its hierarchical structure where the information is propagated from the thing layer to the category layer and from the category layer to the item layer. To be specific, category embeddings are from their belonged things in the thing layers and from their neighbors in the category layers. Due to the limitation of one-way propagating, categories are not affected by the connected items. Then the category embeddings combine with the corresponding item neighborhoods to obtain the thing-based item uh, representation. Uh, in above in above aggregating neighbors process, it obvious that neighbors have different countries to the same elements. We can compare the similarity of the shared thing that a category or items belong to. In the users-based space, we aggregate representation of all users interacted with the corresponding items. Finally, we construct 2-item embeddings for general representations. Our approach aggregates representations of all users interacted with the corresponding items to generate user embeddings. We integrate representation of items and users to make pre-decisions. The model parameter is optimized by pairwise BPR laws. Now we show some experimental study. We construct full data size from GD.com with different domains. The process of the scene determinations follows multiple steps by two different expert teams. We compare our approach with popular and state-of-the-art solutions. In order to evaluate the quality of recommendations, we use NDCG and here ratio to measure the precision. Our approach performs best and improves over them by 6% to 26%. To the best of our knowledge, our approach is among the first to study scene-based recommendations with a formal scene definition. The approach uses the graph neural network to propagate scene information and model users and items to make predictions. We construct and release the real-world data size for the scene-based recommender systems. That's all. Thank you.